Hey guys, today we will be doing 2.7, which is all about dilations. This is the last type of transformation we're going to learn about. It's the last one in the kind of series of translations, reflections, and rotations. And dilations are a little different. We'll get into why in just a minute, but they're the only ones that don't preserve the size of the shape. So you can see here, and these are the finished notes, by the way. You can see down here, this little smiley face, it's a lot smaller than that big smiley face. One of them was dilated to the other. There can be an enlargement or a reduction, but like I said, we'll get into that in just a second. Here's the completed notes if you want to take a look at those. All right, so jumping right into the first page here, just the cover page, we're looking at a dilation. Again, this is the last kind of transformation we're learning about. And it's a transformation in which a figure is either enlarged to your first blank or reduced. Okay, so it's getting bigger or it's shrinking. These translations are actually going to create similar figures. I'm going to zoom in a little bit so I have a little more space to write. They're going to create similar figures. You learned about similar figures last year in 7th grade, and whether you not you remember that is a different thing. But similar figures are figures that have the same shape but different size. All the angle measurements are the same. All the side lengths are proportional to each other, the original image, but they create similar figures. And the scale factor K, okay, K, we're going to highlight that. I'm going to put my header. There we go. That's not what I want at all. There we go. Okay, so the scale factor K is going to indicate how much the image will enlarge or reduce. All right, so K is going to be a value. It's going to be a number. And that number is going to tell us if it's going to get bigger or smaller and by how much. So there's some algebraic rules here. K is the scale factor. I want to just give a little swirly around that. And a K that's greater than 1. Okay, so you can always write greater than. Greater than 1 right there is going to be an enlargement. Okay, so for example, if K equals 2, K equals 8, or if K equals 4, anything larger than 1 is going to be an enlargement, even like 1.1 or a billion or 3 halves or any number that's larger than 1. Then if we have a K value that's less than 1, okay, remember that symbol right here, the symbol down here means less than. That's going to be a reduction. So if we have K equals 1/2, K equals 2/3, or K equals something like 0.7, it'll be a reduction. Anytime it's greater than 1, it's an enlargement. Anytime it's less than 1, it's going to be a reduction. We're not going to talk about negative values for K. We're only going to talk about values above 0, greater than 0. Okay, so if it's between 0 and 1, it's a reduction. If it's greater than 1, 1 to infinity, it is going to be an enlargement. It's getting bigger. Getting into the inside of your notes, we're going to do some examples on how to actually solve these. So our example 1, we're going to be given some points on a triangle. We're going to be given a scale factor. It's going to give us those two things. We have to figure out what the new points of the image are, and we have to figure out how to graph that. I want you guys to remember that the pre-image is always the shape you start with. K is how much you're increasing or enlarging or reducing it by. And your image is the image you get after you dilate it or after you transformation it. All right, so we're going to look at this. The vertices of a triangle are those 3 up there. You guys can read those, draw the figure and its image after a dilation with a scale factor of 3. So our scale factor of 3 is what we want to highlight there. That's going to be really important. And we can also fill out this portion right here, our dilation. It's going to be K equals, that was awful, 3. There we go. K equals 3 is our dilation. Let's see if I highlight this with the yellow, if that goes away. You can still see it. Okay, so dilation K equals 3. Our pre-image is going to be a triangle. That triangle we're going to have as blue. We're going to name that triangle. It's already named for us, but A, B, C. Triangle ABC. You can name it BAC or CBA or whatever combination you want, but the ABC is the nicest because those are alphabetical order. And we have 3 points. Point A is at -3, +3. Okay, remember our X and Y values. Let me go ahead and rewrite that 3. Okay, our X value is the one on the left and our Y value is the one on the right. They're always separated by a comma. Point B is at 2, 1. So that's going to be in our first quadrant in the top right. And point C, -3, -1. It's going to be in our fourth quadrant in the bottom right because they're both negative. Sorry, our third quadrant in the bottom left because they're both negative. For dilation, the rule for it is going to be X times 3 and Y times 3. The reason that's the rule is because we have a scale factor of 3. So all we have to do is multiply each point by 3. That needs to be a Y. So we multiply each point by 3, and we're going to get our new values. So as we look at it, it'll be -3 times 3, which is our X value over here. Then our Y value is 3. We're going to multiply that by 3. Our X value for this one is 2. Multiply that by 3 to get our new one. Then 1 times 3. -3 times 3. -1 times 3. And that'll give us our new points for our image. Our image, we'll do in a pink, kind of pinkish over here. That's going to be A prime, B prime, C prime. Remember those apostrophes always mean the prime. That's kind of our new, our image. That's the new shape that we're getting. Okay, so our A value is -3 times 3. Remember, a negative times a positive is always a negative. So -9. 3 times 3 is +9. 2 times 3, 6. 1 times 3, 3. -3 times 3, -9. -1 times 3, -3. All right, and if we kind of scroll over a little bit, should still be able to see my points because I have my pre-image values up here, so we can just use those. We don't need to look at the blue ones. I just copied those down over there. Okay, so our pre-image, what we started with, our blue one, was at there, -3, +3. So there's a point there. 2, 1 is our next point. And -3, -1 was our last one. Let's see how many tries it takes me to connect those. You know, that's not the best. Okay, that's not the best either, but it's workable. We'll use it. Okay, so that's our pre-image. That's what we started with. We dilated it by a scale factor of 3. So our new points are -9. So go over 3, 3 more, 3 more. Try one more time. Okay, and then +9. So we're up 3, 3 more. Okay. Our B point was at 6, 3. And our C point was at -9, -3. Those came out pretty good. I'm happy with those. So you can see how this this blue triangle is a lot smaller than the pink triangle, obviously. The pink triangle was dilated and made bigger by a scale factor of 3. What that means is each of these sides is 3 times as big as the corresponding side in the blue triangle. So this left side over here, if we count up, it's going to be 1, 2, 3, 4. Would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. On the left side here, it's 3 times as big. You could do that with the top side and the bottom side as well, if you could figure out the distance for those, their size. But I guarantee you they're going to be 3 times as big, as long as all of our math is done right, which 90% sure it is. Going down to example 2. Here you're going to identify the type of dilation and find the scale factor. First part should be pretty easy. All you're doing is figuring out is it an enlargement or a reduction. So this one, from the original image, A, B, C, to A prime, B prime, C prime, did it get bigger or smaller? It got bigger. So it's an enlargement. Okay, it's pretty obvious. And our K value is what we're going to have to figure out. So what I'm going to do is I'm just going to count. Actually, get back here, do that. Okay, I'm just going to count this left side. So this left side's 1, 2, 3, 4 on the image and only 2 on the pre-image. So from 2 to 4, how much did we have to multiply by? And we had to multiply by 2. We had to double it. So K would have to equal 2 there. The next one, we start out with X, Y, Z, and we're getting smaller into X prime, Y prime, and Z prime. So if you want to figure out if that's an enlargement or a reduction, it's getting smaller. It has to be a reduction. All right, there we go. And if we want to figure out what the side lengths are, if we count up 1, 2, 3, 4, 5, 6, 7, 8. Oh man, I'm not doing great with these colors right now. There we go. 8 for the red one, the image, the pre-image. And then for Y prime to X prime, this one would only be 2. Okay, so it's going down. The big one's 4 times as big, which means the small one is 1/4 the size of the big one. Okay, what you can always do with these, just as a hint, is you can always divide the side length of the image, divide it by the side length of the pre-image. Oh gosh. Okay, pre-image is what that says. So you can always divide the side length of the image by the pre-image. So 2 divided by 8 would be 0.25 or 1/4. You can do these in decimals or fractions. Doesn't matter either way. Know how to do both though. For this one over here, if we had 4, the image divided by the pre-image 2, we would get 2. Okay, so that's how you do that. You just divide the side length of the image by the side length of the pre-image. Ooh, there we go. Okay, in example 3, vertices of triangle A vertices of a triangle are these points, and we're dilating with a scale factor 1/2. So we're making this one smaller because this one is a scale factor between 0 and 1, or less than 1. All right, so I'm going to highlight that scale factor because that's important. I'm just going to go ahead and write it down in our dilation section right here. K equals 1/2, and we can highlight that with black. Let's use yellow because that's a normal highlighting color. There we go. So our dilation, K, our scale factor, is going to be 1/2. Our pre-image, we'll use blue again. It's just going to be these points up here. So our triangle, first off, is triangle A, B, C. And we can go down, we can write those points in -2, 0, 2, 4, and 4, -4. There we go. So those are all our points, A, B, and C. since we're dilating by 1/2, our rule is going to be x times 1/2, y times 1/2. So we would do -2 times 1/2, comma, 0 times 1/2. 2 times 1/2, comma, 4 times 1/2. There we go. And 4 times 1/2, -4. Straight mark there, -4 times 1/2. All right, so you see that I'm taking the x value from over here, -2, multiplying it by 1/2. Taking the y value, multiplying it by 1/2. And our image is just going to be A prime, B prime, C prime. So our A value, -2 times 1/2 is -1, comma, 0 times 1/2 is 0. 2 times 1/2 is +1. 4 times 1/2 would be 2. 4 times 1/2, 2. -4 times 1/2, -2. Going a little quick on the math because that's not the focus right now. But if you're having trouble multiplying fractions, positive, negative numbers, definitely review that. It's something that's really important for you guys to know. Okay, so let's go ahead and graph that. -2, 0. Let's use our blue for that one. -2, 0 would be right here. 2, 4, right there, and 4, -4 down there. So our first triangle. Oh, that's rough. Let's try that again. Okay. Just have to go fast and confident. And I hope you don't get too far off. I'll just make my dot really big, and then it'll connect. We can label that. This is A, B, C. And our next triangle is going to be inside of that. We know it's going to be smaller because this is a reduction. So -1, 0 is our first point. 1, 2 is our second point. Into -2 is our third point. That was not fast or confident. There we go. Oh gosh. Okay, we'll keep that. That's about as good as we're going to get, I think. All right, so this would also be, I can use black to label this one just because you'll be able to see it a little better. A prime, B prime. There we go, and C prime. Okay, so our new triangle, the rosy kind of color one there, is going to be smaller because our dilation, our K value, our scale factor, was less than 1. It was between 0 and 1. Please let your teacher know, me, Ms. Spear, Mr. Moore, if you guys have questions on anything. Hope you guys have a good day, and we're excited to get back into phase 3 soon. Woo woo! Have a good one, and we'll talk to you soon.